All right, greetings YouTube. We have this next question from calculus. This is question number 10. It says, consider this function, and we have these different parts. Solve setting the denominator to 0. Is there a c such that the limit as x approaches c of this expression is an indeterminate form? Find the limit as x goes to plus or minus infinity of this expression, and then find the horizontal and vertical asymptotes of the curve. Okay. So the first one is solve e to the x. So if we consider this function, and they're asking us to solve for x, to set in the denominator equal to 0. Okay. So with that, if we have e to the x minus 2 equals 0, we add 2 to both sides. So then we have e to the x equals 2. And then we take the natural log on both sides. So this is taking the inverse of an exponential, right? So that allows this guy to come down and these cancel. So then on the left, we have x. And on the right, we have the natural log of 2. So that result should just be natural log of 2. Because natural log and e are inverses of each other, so when we say e to the power of natural log of 2, they're going to cancel. We're going to be left with 2 minus 2 to give us 0. Okay, consider this function. Is there a c such that the limit as x tends to c of this expression is an indeterminate form? Indeterminate form means that we finish with something like either infinity over infinity, or if we finish with 0 over 0. So like I think when x is the natural log of 2, on the denominator, that'll give us a 0. But in the numerator, that'll give us what, 14? So if we were to say, is there a c such that this would be an indeterminate form, we would say no. This would just be a no. Because we can't find a c such that it'll give us infinity over infinity. Or if it gives us 0 over 0, right? So is there a c such that this has an indeterminate form? We would say no. Okay. And then to find the limit as x goes to plus or minus infinity. I'm going to start with the plus infinity first because it's just easier for me. Okay, I'm going to see, can we do something similar to like what we did before? Let me see. Okay, if we factor out e to the x from all the terms, right? So if I'm considering the limit as x goes to infinity, again, we want to factor out e to the x over e to the x. So at the top, that's going to leave us with 7. On the bottom, that's going to leave us with 1 minus 2 over e to the x. Okay. So then this is gone. Now if we take the limit as x goes to infinity, essentially what that's given us, that's going to be what? 2 over a large number. So this guy is going to tend to 0. So ultimately it's going to leave us with 7. Right? So we're saying as we go off to the far right, the function is going to get closer to 7. If that were a negative infinity, okay, I think we need to actually do that one. So if we go to the far right, it looks like it approaches 7. Now let's redo it with the limit as x goes to negative infinity. So if we're going to consider the limit as x goes off to the far left, or negative infinity, again, we have this e to the x minus 2, 7e to the x. So remember, a negative power means it's a fraction. That will go to 0. Okay. So x goes to negative infinity. Conceptually, essentially what this is becoming is like, this is like 7 over infinity, right? Because the e has to go down because it's a negative power and it blows up to infinity, right? And then on bottom, a negative infinity means we're going to have what, 1 over infinity minus 2. So then this guy, that tends to 0. This tends to 0. And that's a negative 2. So then ultimately, really what we have going on here is 0 minus 2 under 0, which is 0 over 2, which is 0. Right? So it looks like as we go off to the far left, the function tends to 0. And as we go off to the far right, the function tends to 7. Okay. At least that's what I got when I did it here. Almost like an S shape. Okay, that was that one. Find the horizontal and vertical asymptotes of the curve. I don't have my curve handy. Sorry, I'm just trying to get a copy. Here it is. So the vertical asymptotes are going to be those values of x that make the denominator 0. And I think we did that already, right? So the vertical asymptote, I think we said it was x equals the natural log of 2. Because the e and natural log cancel each other out, it's going to be a 2 minus 2, which is a 0. And we don't have 0 on top. So the vertical asymptote should occur when x equals the natural log of 2. Mm-hmm. So this looks like our vertical asymptote. And then for the horizontal, I think we have 2 of them. So as we go off to the far right, so that was the vertical. The horizontal asymptote, it should be like y equals 7 or y equals 0. Like when we go up to the far right, it tends to 7. As we go to the far left, it tends to 0. These little underline with the double slashes, that's just me highlighting the final answer that I got to try to make it pop off the page. We usually put those in a box. I'm just trying to highlight it. Okay. I think that's okay. I think there might be one more part. Was that it? That was it. So that last part, I think it was just synthesizing or interpreting the results that we got. Okay. So hopefully that's okay. And with that, we're going to end the session here. And from one beautiful mind to another, take care. Peace.